Hey guys, I just want to talk a little bit about sketching some quadratic functions, specifically when they're in turning point format. So that's this function that we see over here. Y is equal to a times x plus b all squared plus c. And that's for a constant number a, constant number b, constant number c. And we like this format because a, b, and c, whatever these numbers might be, they change the quadratic parabola, or the parabola that the quadratic is creating, in pretty predictable ways. So let's have a look. Here's a bit of Mathematica Wolfram code. Shout out to Stephen Wolfram. Look him up. He's a madman. But anyways, don't look him up. Actually, it'd be a waste of time. But anyways, here's a function, and you can see I've just defined this function to be the turning point format for a quadratic function here. A times x plus b all squared plus c. And I'm plotting this function over a domain of where x is -5 to +5, and a range where y is -10 to +10. You can see that on my grid down here. And we're just manipulating this plot over a, b, and c basically. I just want to see what's going to happen to this plot as I change a from -5 up to +5, as I change b from, a, b, and c from -5 to +5 basically. What's going to happen to the parabola created by this function as I change a, b, and c from -5 to +5? Well, let's start with the basic quadratic here. This is y is equal to x squared. A is starting at 1, b is 0, c is 0, so this would just be x squared. If I increase the value of a from 1 to 2, that's what happens. From 2 to 3, that's what happens. 3 to 4, 4 to 5. So what happens is I increase my a. I'm essentially... well, you can see that the gradient of this quadratic, as I go from the origin to the right, it starts off as starts off as 0, the gradient, and then gradually the gradient starts to increase as we move along this slope. If I increase a, you can see that the speed at which my gradient is increasing increases, right? So it's kind of tricky to think about, but I'll just say that one more time. So as I increase a, the rate at which my gradient increases speeds up. So here, our gradient is increasing by, let's say, a factor of 1. Here, my gradient is increasing 2 times as fast, by a factor of 2. And so on. Here, our gradient is increasing by a factor of 3, 4, 5, and so on and so forth. In other words, A dilates our parabola, right? A dilates our parabola. It changes the rate at which our gradient increases or decreases. Alright, so the reason I say decreases is because if a becomes negative, now we have a reflected parabola. And when a is -1, that's just a complete reflection of a being +1. And same for -2, -3, and so on. The negative symbol is really just a reflection about the x-axis. Okay, let's get this back to... Now for b, that's my constant inside my brackets here. If I increase b, so it's gonna act kind of randomly, b, just to give you a warning. It's to do with a horizontal translation. That just basically means if I change the value of b, I'm gonna be moving my parabola left or right along the grid. So let's start at 0. And if I were to increase b, so let's look at this function right here. If I increase b, have a think, like which direction would this parabola move? Where do you reckon it would move, left or right? In my opinion, or when I first saw this in high school, I was thinking like x plus b. If a b is positive, we're going to move in the positive direction along our x-axis. But let's see what happens. So b increasing in value moves the parabola left, and b being negative, that's going to move the parabola right. So just keep that in your mind. Don't forget that. That's really important, and we'll see why soon, I promise. But for now, just remember, if b is positive, so x plus 2, we're going to have a shift to the left. If b is negative, x take 5, we're going to have a shift to the right. Okay, c, that's the final constant we're adding at the very end. This is going to be a vertical translation. If I change c, it's going to shift up or down. And this behaves kind of in a more predictable way, or at least how we'd expect. If I increase c, if I'm adding 4, I'm going to shift my parabola up by 4. If I'm taking away 5, I'm shifting my parabola down by 5. So c is a bit more, it behaves a bit more predictably. But anyways, that's just how a, b, and c change the parabola created by our function, our turning point quadratic function, basically.